In this short video, we're going to look at systems that are trigonometric, radical, and piecewise functions, or a combination, really a combination of these three. The first example that I wanted to show you is a system. And remember, that just means more than one equation. So we have two equations here, so that puts that in a category of a system. The first one is a trigonometric system because it is sine. And the second one is radical because of the square root. And it's also a piecewise function because of the x is greater than or equal to 4. So we kind of got the combo here of the trig, of the radical, and of the piecewise. So we want to make sure that our students understand that systems aren't always just two lines or a line and a quadratic or a line and maybe an absolute value graph. It can go further beyond into graphs of trig functions, radical functions, and piecewise functions. So my red graph is my sine graph. You can tell that I use Desmos here. My blue graph is the square root of x and then minus 2 on the outside. So if I looked at this entire graph, it would actually start at -2 and it would progress this way. It would be a curve and it would progress up to this way. But we're only graphing this piece of the quadratic where x is greater than or equal to 4. So that's why this graph starts on the x-axis at 4, because it's a piece of the graph of the square root of x subtract 2. And again, when we're solving, we're looking for intersection points. So we can see, even though these are kind of ugly points because I made these two equations up, but definitely this piece of the radical function crosses or intersects the sine function at two ordered pairs. So these ordered pairs would be considered the solutions to our system. So again, we have a sine graph, we have a radical graph, and we actually have a piece of the radical graph. So we've got all three of those functions in this one problem. So final answer, if they're asking for your solutions, would be these two ordered pairs. My next example is a linear function. F of x equals 2x is linear, and g of x equals the square root of x plus 3 is another radical function. Here we have one intersection point, and I highlighted that in Desmos so we could see the 1, 2. I also wanted y'all to look at the tables. So I think this is something that your TI-84 can do for you, and so can Desmos. So I wanted to show you how to get these two tables that I have. So when you have your functions in, so if you'll click into this first equation and click the wheel, you can click this table and it will actually pull up a table of ordered pairs that are on your graph. So this is the red graph, so this is the line. So we have -2, -4 right here, -1, -2, and so on. So these are some points that are on the f of x equals 2x graph. It's not all the points, but it gives us a nice little set of 5 ordered pairs. Again, if you click on that gear shift and you do table for this second equation, your square root of x plus 3, it also gives you some ordered pairs that are on the blue graph. Not all of them, but it looks like it gives you 5 nice points. I'm going to go back to my PowerPoint slide. So I really think it's important. I know a lot of times we see this in our OHS and also in the ACT, where we are just given the tables and asked to find the intersection point. So since we can really see the picture using the graphs, we see the intersection point of these two, of this system, of these two graphs is at 1, 2. And if we notice, if we look at 1 on the table of the red graph, and we look at where x is 1 on the table of the blue graph, we see that they both have the same y value. So sometimes they just give you a table. They don't give you a graph. And so when you're looking for an intersection point, you're looking for a point that's in both graphs, the exact point. Okay, so both of these have the point 1, 2. That proves that 1, 2 is the intersection point. So again, systems don't just have to be linear or quadratic. They can also extend to trigonometric, radical, and piecewise functions.